morning, students. Today we are going to start chapter number 10, Carbon and its Oxides. Two common oxides of carbon are carbon dioxide and carbon monoxide. Carbon dioxide is produced during respiration. It is also the gas utilized by the green plants for photosynthesis. Carbon monoxide is a poisonous gas produced when fuels burn in insufficient supply of oxygen. In this chapter, we are going to study about both the oxides in detail. Carbon dioxide is one of the most important constituents of air. It constitutes about 0.03% of the atmosphere by volume. Carbon dioxide was first discovered by Van Helmont in 1630 by burning the charcoal in air. He named the gas carbonium. In 1775, Joseph Black obtained carbon dioxide by the action of dilute acid on the metal carbonates and called it fixed air. Later, Antoine Lavoisier in 1783 discovered its composition as an oxide of carbon and named it as acid carbonic. Later it was named as carbon dioxide. Carbon dioxide is found in the free state as well as in the combined state. In the free state, carbon dioxide occurs in the atmosphere to the extent of 0.03% by volume. A large quantity of carbon dioxide is released in the atmosphere during the combustion of fuels containing carbon such as petrol, diesel, coal, etc. Carbon dioxide is also produced during the process of respiration, the decomposition of the dead organic matter, and fermentation. It is also present in the rocks of volcanic regions. In natural water, carbon dioxide is present in the dissolved state. In the combined state, it occurs as metallic carbonates and bicarbonates in the earth's crust and sea shells. The major compounds containing carbon dioxide are limestone, magnesite, and dolomite. Different methods for the preparation of carbon dioxide. By burning carbon or its compounds. Burning of carbon like charcoal, coke, or carbon compounds such as methane in air produces carbon dioxide. Carbon plus oxygen on burning produces carbon dioxide. Methane plus oxygen on burning produces carbon dioxide and water. Next method for preparation of carbon dioxide is by heating metal carbonates or bicarbonates. Certain metallic carbonates and bicarbonates decompose on heating strongly and produce carbon dioxide. Examples: copper carbonate on strong heating forms copper oxide and carbon dioxide. Sodium bicarbonate on heating produces sodium carbonate, water, and carbon dioxide. Next method for the preparation of carbon dioxide is by the action of dilute acids on the metallic carbonate and bicarbonate. Certain metallic carbonate and bicarbonate react with dilute acids to form carbon dioxide. For example, calcium carbonate reacts with dilute sulfuric acid to form calcium chloride, water, and carbon dioxide. Sodium carbonate reacts with dilute sulfuric acid to form sodium sulfate, water, and carbon dioxide. Sodium bicarbonate reacts with dilute hydrochloric acid, forming sodium chloride, water, and carbon dioxide. Sodium bicarbonate reacts with acetic acid, which is also known as vinegar, to form sodium acetate, water, and carbon dioxide. The laboratory preparation of carbon dioxide. Carbon dioxide can be prepared in the laboratory by the action of dilute acid on the metal carbonate. To show the preparation of carbon dioxide by the action of dilute hydrochloric acid on calcium carbonate, we will do an activity. For this, the materials required are marble chips, which is calcium carbonate, dilute hydrochloric acid, a Wolf's bottle, a delivery tube bent twice at right angles, a gas jar, a thistle funnel, and 2 rubber stoppers with a hole each. The procedure for the laboratory preparation is as follows. We take some marble chips in a Wolf's bottle. We fix the rubber stoppers in both the mouths of the bottle. Through the hole of one of the rubber stoppers, pass the thistle funnel, and through the hole of the other rubber stopper, pass the delivery tube. Fit the other end of the delivery tube in a gas jar. Make the apparatus airtight. Now we pour some dilute hydrochloric acid through the thistle funnel so that the lower end of the funnel is dipped in the acid. As soon as the acid is poured, a vigorous chemical reaction takes place. We observe that carbon dioxide gas is evolved with a strong effervescence. The first few bubbles of the gas are allowed to escape since they might contain air and acid as impurities. The gas is then allowed to pass through the delivery tube into the gas jar, where it is collected by upward displacement of air. Since carbon dioxide is heavier than air, that means carbon dioxide will settle at the base of the gas jar. So we conclude by this reaction that marble chips react with the dilute hydrochloric acid to produce carbon dioxide. Chemical equation for the laboratory preparation is as follows. Calcium carbonate reacts with dilute hydrochloric acid, forming calcium chloride, water, and carbon dioxide, which is collected in the gas jar. Calcium carbonate is preferred to other metallic carbonates since it is cheap and easily available. Carbon dioxide is not collected over water since it is highly soluble in water. So it is collected by the upward displacement of air. Dilute sulfuric acid is not used in place of dilute hydrochloric acid as it forms calcium sulfate, which is insoluble in water. Calcium sulfate deposits over the marble chips and stops the reaction.